Toyota says they are going to detune or reprogram, sorry, I shouldn't say detune, reprogram all of the Tacomas eventually to prevent this front differential failure that you saw with TFL's truck. As you might remember, TFL had this happen when they were doing light off-roading, but they were in 4 low with the rear locker on. Now, this is Sheldon Brown, the Toyota Tacoma chief engineer. He was just interviewed by TFL, and they sort of gave us all the engineering speak of why this happened in this truck, in TFL's truck. We're going to go over that right now. I'm going to give you my initial reaction and off-the-cuff reaction, and I think it's interesting, some of the stuff he said in this video, which is why I'm doing my video on it, because I personally just wish they were designing the trucks differently. I actually don't blame Sheldon or the engineers, but I think it's very telling kind of the direction that Toyota is going. So let's get into it. So the first thing Sheldon does is he talks about the part that failed. So let's watch that real quick.
We thought, okay, this sounds like you had functional rear drive, but not front drive, loss of traction in the front drive. So it sounded like it was part of our ADD assembly. And in fact, it was that was the root cause ultimately. It was something we call the intermediate center shaft, the IC shaft. And that is a kind of a fused failure point. It is serviceable. I'll cut to the chase. Effectively, we did a pretty thorough investigation. We wanted to check the pin, the needle bearings, and we wanted to make sure the pressures are set. We checked all the gear teeth or proper backlash. Great news is that all checked out. We went through then and we did all of our material checks and we did our dimensional checks on the actual IC shaft itself. So the other nice thing is we were able to pull some of the panel data, so we could see what was happening, what was the torque request, what was the mode that was the vehicle was operating, 4 low, 4 high, for example, multi-train select, what mode was it in, etc. And this tells us a picture of what's happening through the vehicle, and it's important for us because we want to make sure that the vehicle electronic systems were operating as anticipated. So that did take us a while to go through all of that because we wanted to make sure that we were thorough.
It is good that they're going through, a very thorough investigation of this, which they should. I mean, they probably tested the crap out of this truck, and then they're surprised that it failed under such a light circumstance. So they tried to recreate the combination.
In the end, what we concluded was that there is a very rare, but obviously in your case, real customer use scenario where our traction control logic can exceed the overall driveline system strength.
It's a little bit odd. He says that it's rare, but a real use case that the traction control logic can exceed the overall driveline system strength. This sounds a lot like what they did with the manual transmission when they detuned the manual transmission a little bit because they can't really control your right foot with software as much, so they would, rather than overbuilding the drive system to a point where maybe it could handle like the most extreme case of you dropping the clutch in a manual, or in this case, the most extreme case of maybe the MTS going crazy and braking too much when there's no friction blocking the wheels. They would prefer to just control it with software than to, overbuild the system in this scenario.
Is a little bit difficult to explain because it's a function of multiple different sort of stars need to align, if you will, in order to achieve this situation. It's probably why we never caught it in screening. But it is a situation that only would happen in 4 low. It would have to be in a multi-terrain selection sort of area, contributing to the fact that the lockers, the rear locker was locked. This just means that more of the torque is going to the front of the vehicle. And effectively what in this particular case happened, the long story short, is it sort of sent all of the torque to the front, and then when as you were starting to slide and you saw the vehicle start to slide this way, all the torque went to the one wheel, and then the brake really quickly grabbed it.
So that part, I just don't agree with Sheldon on this. He says that all of the torque went to the front wheels. Let's watch that right now. And as you can see from this under the truck camera, that there's torque going to all the wheels, and they're all behaving similarly. They seem like the MTS is braking on them, in various ways. And in addition to that, the truck is slightly off camber, it looks like, to the left. So the weight is actually on the left side, which I think is the stronger side when you look at the internals of that front axle anyway. When you look at that, there's actually a little less weight on that front right wheel, which is why it probably was putting the brake on that one a little bit more. So watch this really quick.
That in and of itself shouldn't have actually, broke the system. But when we start to add additional contributors,
Right there, all the wheels are spinning. If you can see down here, these wheels have, even some dirt. Actually look like maybe they have a little more friction on the bottom part, but this rear end and this part of the drive system is going to be slightly beefier than what you'd find in the front differential.
factors such as where we were through the RPM range, as well as where we were with the torque converter in terms of efficiency, and a number of other I'll say contributors, we did exceed it. And we exceeded it by about 1.7%. So narrowly exceeded the margin. So I tell you that to say that from a fundamental standpoint of view, design and I'd say what is the risk to our customer, pretty doggone rare.
I have no idea how they figured out that they exceeded their driveline thresholds by 1.7%. In this scenario, when I watched the video, I personally don't think that it should have snapped, and I think most people don't. And Roman goes on to say as much. They did exceed it. They are admitting that they exceeded the what that front drive line and the intermediate connection shaft can withstand.
The other, I think, good thing about this truck is that new 4-cylinder turbo gets a lot of torque down low. So you don't have to wind up the engine to 6,000 RPM to get the torque. There's that saying that people buy horsepower but drive torque. It's what you feel. And so I think, at 1,700 RPM, you get maximum torque out of the 4-cylinder. Is that right? Or did I get that wrong?
No, you're right on it. Yeah, you're spot on.
And so go ahead.
No, please.
So I didn't have the pedal mash down. I wasn't pushing it hard. But I didn't need to do that because there's all this torque down low. And so
that part was a little comical. It's like they can't just get through the video and talk about the engineering. They got to tell you how this is better than the V6. You don't even have to rev it up like the V6. You get all that torque down low.
My point I wanted to say is if you're out there and you're worried about this is not something that you need to worry about. Now, again, we're working on a countermeasure within our software. That's well underway. In fact, we launched all of our hybrid vehicles because we were able to get those in time. We applied this software logic change that will prevent that situation from happening. We're working now to figure out how best to sort of bundle this and get this out to those who might have a vehicle in the market.
I think that's interesting. So they already applied this software change to the hybrids, which tells you what you need to know, right? They knew the hybrids have way more torque than the non-hybrids. So what they're doing is reprogramming the software, the MTS system. They're definitely detuning, reprogramming, maybe doing something there with a combination with the MTS and how much brake force is being applied in order to compensate for the extra torque from the hybrid. And then they're going to put that same programming in the non-hybrid now that they've determined that there is this edge case that blows the front driveline.
As a general rule, to sort of assuage concerns of is it super sensitive? The short answer is no. And we're using, again, a very tried and true design, obviously updated and sized up, gauged up accordingly to the new torque.
And I do like that, at least he says that, with the new Tacoma, they did up gauge the size of, you would assume, the intermediate shaft, the connection shaft, the drive lines, anything that they're using in the system. You would hope that they upsized it to accommodate for the torque. Not as much as me personally, I would love to see them upsize it more, but at least they've done something. We haven't seen a ton of these fail. This is the only one we've seen fail, and they'll talk about that here shortly.
At this point in time, we haven't determined exactly how we're going to roll that out, but more information to come probably later this summer. The reason for that is it does touch a couple of different systems, and so we just need to demonstrate that any system that's being touched, regardless that it doesn't have any implications to any of the certification requirements. Again, that's not to say that we're doing anything that would change it. We just have to demonstrate to agencies and other places that anything that we do doesn't have it. So that takes a little bit of time for us. That.
Interesting. He talked about how they have to, just kind of gives you guys and everybody an idea of, how much the government and all these agencies play a role in Toyota. They can't just re-engineer the truck, get it out to customers and roll updates really quick. They actually have to pass some certifications and go through, I'm sure, legal, just like all the speak that Sheldon has here. He's, on one hand, he's saying, we can't certify larger tires on the Tacoma, but we know that you're going to put larger tires on your Tacoma. So he has to balance. He has to play a balancing act here. You know, he's got legal teams. He's been told what he can say, and it's probably frustrating for the engineers, I'm sure.
Extensively. We track this pretty much weekly, and we're looking to see if we see any other differentials breaking. And we don't have any other warranty claims, and we don't have any other service parts claims. So if someone decided to, buy it on their own dime and backdoor it,
so that's a good sign. I mean, TFL is the only one that's had this snap. They've got 40 some thousand trucks in service right now. Now, granted, a lot of people didn't get to see these in winter. TFL was a really early adopter for this, so. In the specific scenario that TFL has in the winter, snow and ice, maybe some of you Canadian guys are going to figure this out the hard way, but I'm guessing they're going to come out with this. They said they're going to come out with this software update in the summer, so it's probably not going to become an issue for anyone in the future.
there are other areas, for example, if you go into mud mode or into sand mode, where we might start you in second gear, as an example, just because we want wheel speed in this case, right? And we want to slow how much we're going to brake. So we may apply some pressure, but probably less pressure in those cases. And the nuances that.
So that kind of gives you an idea. I mean, there's a lot going on with the software and the MTS system, and especially what terrain you select. As you said there, sometimes they start in second gear, so there's a lot of complexity that goes on. But that's part of the problem with these new trucks, right? You have all this crazy complexity, and instead of maybe taking the approach of building something just mechanically maybe a little overbuilt because you don't have the technology or software to deal with that. They kind of mechanically thread the needle, and they don't underbuild them, but they build them as cost efficient as possible for Toyota to build them for what 99% of people are doing. And then, that 1%, yeah, you might hit these edge cases now, because a lot of the torque, a lot of the situations people get themselves into, they can actually manage that with software so that you're not breaking systems that are maybe mechanically designed a little weaker with thinner parts or weaker pieces, but or maybe weaker than maybe what they would have designed like 10 or 15 years ago without as advanced of software technology.
As a guy, off road, I got to start to change my habits a little bit and recognize that, I'm actually, I saw a couple of the comments that, that thing just, snapped like a twig. The reality of the situation, there was massive stress through that drive line, because we're full torque. I think you were maybe at 25 to 2,700 RPM, if I remember correctly, but, full in the torque band.
So he's saying that, people should probably consider changing their driving habits a little bit, don't floor it or whatever. Roman goes on to tell him that he wasn't flooring it. I think that this was not a situation where he was driving hard, and Sheldon admitted that, but I don't think that people should have to change their driving habits, but I get what he's saying. These engines are a lot higher torque than they used to be, so don't go out there and just floor it and try to break your truck, because these things might actually break. There's a lot more torque than what we've had in every truck, really, right? You've got the Ego Boost, the Tundras, all these turbo diesels, all these turbo gas engines. Everything has more torque than it used to have. So, there's going to be a greater chance of driveline and breakage in certain areas.
Where we let our customer down. That's something. And that's why we have this EDR group, because we want to make sure that we're delivering perfect trucks. And we're humbly reminded at times that we fall short of that. But that is, make no mistake, that is always the goal.
So he did just talk about their EDER, which is their early detection, early resolution. I would respectfully disagree with Toyota on this one. Early detection, yes, like the Tundra, they detected the engine debris issue early. Early resolution, they did not have. So we still have 2024's failing 3 years down the road. So EDER is failing Toyota in some respects. In this case with the Tacoma, I think it's actually pretty early, and it's working. So I wish they had done something like this for the Tundra. So Sheldon did say, he can't build a 100% bulletproof truck, which I agree with. I don't begrudge them for that. However, I there's always a caveat with me. I'm just, when folks are spending $50 to $70 to whatever $80,000 on these vehicles, I think that's why you see YouTubers and all these people getting kind of up in arms about failures on the vehicles, because now they cost 20, 30, 40% more than they used to, and people are really expecting them, when they spend that kind of money, they expect it to handle everything, right? And when Toyota goes and shows you the TRD commercials and it's just, ripping through the dirt and jumping and all these things, it gives you this illusion of ultimate durability under any circumstance. But they're saying, that's not really the case. In my line of work, we're given specifications to build something. What we typically do is we go find the 5 worst use cases for that software. We find the pain points, and then we find the 5 worst use cases. And then we'll build the software around those use cases to try to handle them. And then we can handle those 5 worst use cases in the pain points in the application. And then we know that the thousands of other pieces of information that are sent at this software system, the hardware is going to be able to handle it. That's how we build software. Now, we're not doing this at scale where I work like Toyota is, and we're not counting beans. So, it's a different outlook. It's you just have to take it for what it is. I appreciate Roman and Sheldon going through this. They didn't have to do this interview. Like, Toyota could have just not said anything about it, right? Toyota could have just not come out. Sheldon just goes away, doesn't talk about it. There's only one diff failure, and they came out and did a YouTube video about that. So I kind of respect Toyota for doing that in the end and giving us this information. Most companies aren't doing that. They're not coming on these YouTube channels and getting down to the engineering level and explaining what happened. Whether we agree with how they're building the trucks or not is, that's a personal thing. And Sheldon, I kind of feel for the engineers on this project, because that Sheldon and the engineers aren't just given an unlimited check, right? They can't just be like, oh, let's put the biggest Dana axles in this. Let's just overbuild the crap out of it. They're not allowed to. So, Toyota corporate is going to push down profit initiatives all the way down. They have constraints to build this in. So, I can't really blame the engineers. The engineers could build some bulletproof vehicle if they really wanted to. The problem is it would cost too much and no one would buy it because of the price. Let me know what you think about this. I'd love to hear your comments. Thanks for watching. Till next time.